Bandwidth for changelog is provided by Fastly. Learn more at fastly.com.
I'm Marc-Antoine, and it is go time!
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. Welcome back, everybody, for another episode of Go Time. Today's episode is number 46. And our sponsor for today is TopTal. Today on the show, we have myself, Eric St. Martin, and also on the show, who is the birthday boy today, Mr. Brian Kettleson. Say hello, Brian.
Is it really episode 46 on my 46th birthday?
It is.
That's precious.
Wow.
Incredible.
That's so special.
And I'd say we'd sing for you, but we tried that once, and latency was terrible.
No, we're singing. Damn it. There will be singing. Marc-Antoine will do it. He already told me.
And also on the show, we have Carlicia Pinto. Say hello, Carlicia.
Hi, everybody.
And as Brian just said, our special guest for today is Marc-Antoine Ruel. Now, do you want to give everybody maybe a little bit of background of who you are and kind of what you're working on, and then we'll get into your project, which was recently released, which is you just call it Perif, or do you pronounce the IO in the domain?
Excellent question. I actually have no idea how to pronounce it. So
Doesn't pronounce it because he never says it.
Exactly. So I'm Marc-Antoine. I've been working at Google for 10 years now. Before that, I used to work with many different companies that failed in various ways. So interestingly, I work in Python most of my job. But I really like doing Go. So for personal projects, I do Go projects. So the one that has been the most popular is Panic Parse, which is a very simple tool to process stack traces. So yeah, that's pretty much it. I live in the Ottawa region in Canada. So it's a pretty nice region. I really, really love it there.
Excellent.
We're all actually considering moving up to be near you because we're all going to lose our healthcare today. So Canada, we hear, has a very nice healthcare system. Is that true?
Yes. Well, actually, it has its own kinks. But it's really only 2 days.
But you have it.
Yeah, but you have one.
But the fun thing is, only really today I realized that in the United States, you cannot have chemotherapy for free. And it was such a given for me that was like, oh no, people actually die because they cannot afford treatments. And yeah, it's just sad. But yeah, I mean, in Canada, the difference is that if you're rich, you don't actually get that much better healthcare. So yeah, that's different challenges.
It took me how many minutes to get into politics?
Right?
Wow. That was a record.
He was just sitting on that button.
But today is a tough day.
It is a very tough day.
Yeah.
So on a more exciting note, your project, Perif, I'm going to say Perifio or Perifio. It rolls off the tongue better than just Perif, I think.
That's true.
So you haven't learned to pronounce it yet. So we're gonna make up the pronunciation on the show.
You have heard it here first.
Yeah. That's great. So the fun thing is that it started in 2014. Back in at that time, there's a company named GroupGets, and they wanted to test their platforms. It was a small startup, and they started to do Googlers only selling of the FLIR Lepton, which is a infrared camera. And so I bought one. And I was like, yay, I have an infrared camera. And now what do I do with it? So then at that point, I decided to say, well, I'm going to write a driver for it in Go because I wasn't really happy with the code that was provided with the device.
Now, I have an important question for you. Is this infrared camera heat proof?
No. So it's actually designed to look at temperatures. So the FLIR company makes infrared cameras to be able to read temperature via infrared images. So it's not like the low light cameras that you can see in the dark. It's really just about looking at temperature.
Still sounds interesting.
I already see where you're going with this, Brian.
We'll get there.
Yeah, that's actually, I know what's your question. So I don't recall what's the highest temperature it can register. So, but I think it's
Probably
limited.
melt.
It will probably melt. But yeah, so basically, I started writing code for that in early 2015. So I had a lot of fun with it, but the device was kind of tricky to interface, and I had a lot of trouble keeping a good signal. But on the other hand, I started learning like with the WebSockets and a lot of things that I didn't know about before. So I used it as a learning experience, and it was really really cool. So and then in the summer, I attended the first GopherCon, and I saw the GoBot room, and then I realized it existed because I didn't realize before. And by the time it didn't support SPI protocol, which is needed for this camera, so I was like, yeah, okay, too bad. And but then eventually I just dropped the project on the floor. And later in the Christmas period, then Brad Fitzpatrick did his Christmas light on Christmas evening. I was like, oh, that's a neat idea. So I bought a few LED strips. They are quite expensive in Canada, so Amazon doesn't really have any roll of them. So basically, I bought them directly on Alibaba. So I bought like 12 rolls of 5 meters each, and then sold a few back to colleagues, basically. And so I became a pusher of LEDs. And I decided to start a project that I named Leebox, basically, and wrote my own driver for that. And the reason I decided to go with this one in particular is because I wanted to do night lights for my children's room. So these can go really, really dark. So actually really faint in the brightness, because they have two different PWMs that you can use simultaneously to lower the amount of light it emits. So because of that, I was actually able to make them so that basically you can have a very, very faint lighting that you can keep in the room for the whole night. So it's pretty nice.
That's fantastic. I have long, very long, maybe 15-meter LED strips under the bunk beds in all of my kids' room, because underneath the bunk bed gets almost no light at all. So they even use those during the daytime, but it would be awesome to be able to control the brightness of those.
Yeah, that's cool. Otherwise it becomes but depending on the kind of light, it can be very, very bright, and then it's kind of aggressive, especially in the night. So having the possibility to have very, very faint light is really, really nice.
Now, this is controllable through the SPI bus, or this is just like doing PWM or something?
No, it's SPI bus. So one of the nice thing about these lights is that each of the device has its own set of PWMs. Actually, there's 4 PWMs per light. So one per channel. So basically one red, one green, and one blue. And then there's an overall one. So basically there's an overall brightness and then one per channel. So what I did in the driver is that I try to use the channel PWMs, and one I go to the very, very dim coloring, then I start using the other one. So basically I use a gamma ramp, so that, for example, if you ask a 50% light intensity, in practice you get around 10%, because that's how the eyes see the light. So one of the first thing I did was to actually get this roughly 13 bits of precision and put it back into 8 bits of precision, so that I could have 8-bit pixels, but by still extending the brightness as perceived by the eye. So that has given really, really nice results.
Nice. Now, is this like do you have like a Raspberry Pi or like a BeagleBone running a Go process that controls this?
Yeah, so I started with the Raspberry Pi. I really wanted to run well on the Raspberry Pi 1 just for the fun of it. I wanted to see if I could do performance optimization on that. And eventually I just bought a fair chunk of Raspberry Pi 3s. The main advantage of the tree is that it boots faster. So when the power is cut out or whatever happens, it's much faster to boot. So yeah, but the way it works, it's really not Raspberry Pi specific at all. So basically, as long as you have a SPI bus, it just works.
That's very nice.
So then I started to take a look at more serious projects, and so once it started working, it was closer to summer of last year. Then I decided to look at. Well, actually, I started talking with Yana, and I saw that she had been working on standardizing SPI protocol there. So I was like, oh, okay, but I've been working on this other side project, and I decided to start looking at how we could reconcile that. So a lot of discussion happened during the summer, and eventually I got one of the things that I really, really wanted to have was to have a real driver registry. And one of the foundation of Perif itself is that you can really have device driver in the light sense, in the sense that it's really just classes, Go structs, basically. But I wanted to have a way so that they would just appear automatically and be discovered by the library. And that's really one of the foundation I wanted to explore. And one of the reasons is that actually in a previous life, I used to do kernel development on Windows at Matrox, a video card maker in the actually in the late 90s. And I was doing industrial imaging over FireWire 1394. And it was really nice. Like I had like 1,000 frames per second cameras, which was very, very amazing at that time. But I was working on Windows NT4, so the trade-off was there. I was stuck on a really crappy OS. But on the other hand, I got to learn a lot about kernel development. And for example, Windows NT4 didn't have any native support for plug and play, so it was really a pain to work with. But then Windows 2000 came out, and it was awesome, obviously. But at least it worked. And so basically, this concept of managing discoveries of device. Well, actually, at the time, I didn't want to have discovery of device, but I wanted to have the discovery of the functionality provided by the host. So I experimented with that for many months, and I finally got something that I liked, maybe in October or November of last year.
How do you encapsulate that sort of? I mean, it's almost like service discovery for the host. How does that look at a conceptual level?
Yeah, so basically, I wanted to create a registry. So basically, what happens is that there's the each of the driver that you want to register. Perif provides a few; they are registered automatically. When the driver specifies the dependencies it has. So, for example, right now I'm working on a DMA controller driver. So basically, it depends on the fact. For example, for the Raspberry Pi CPU, it's the BCM. I forgot the number, but 2735 or 37. It's not worth trying to load a driver, for example, the DMA, if it didn't load at least the GPIO driver, for example. So basically, it registers a DAG. So it's really a directed graph of all the drivers, and each of the drivers specify which other drivers they need to be able to be worth trying to be loaded. So the library makes sure that the DAG is actually good, valid, there's no cycle, things like that. And once it detects that it's valid, it tries to load the drivers in parallel as much as it can based on the dependency tree. So basically, it calls the initialization function on each of them. So the driver can return 3 different states. So either it's ignored because it's just not relevant on the platform. So, for example, the driver for the chip pinout is not worked if it's not running on the Allwinner CPU. There's also it was valid and it worked, or it was valid and it failed to load. So, for example, on most platforms, if it's not running as root, by default, most of the operating systems, the Linux distributions are not configured in a way where you can use, for example, SPI arbitrarily without running as root, or yourself modifying the access on the sysfs or devfs file, virtual files.
So all of this is meant to kind of create an abstraction, kind of like layers.
Yeah.
Because I noticed that you had some drivers for like Maxim temperature sensors or the Dallas temperature sensors and things like that. So basically, you would include one of those, and then it tries to load, the SPI driver or something like that.
Actually, it's the reverse. So when you start it up, it tries to discover all the hardware features of the platform of the host itself, but it doesn't try to discover anything attached to it. So to not start interfering or anything like that. So then it's really up to the application, basically.
Okay, yeah. So it tries to discover whether things like SPI or I2C or UART is available on the board.
Yeah.
And then from there, you kind of take control of those connections.
Exactly. So for example, if you take a chip, by default, SPI is not enabled. So it will not be loaded. So then when you request SPI bus, SPI connection, it will refuse because it didn't find any. So if you then follow the instruction to enable it, then after that it will be available. And when you request one, it will give you the first one available. Well, there's only one, so it's simple in this case. But the general idea is really about all the underlying platform support to have that as automatic as possible, basically. So the part of the device drivers, basically, I started writing device drivers because I felt that I couldn't implement the underlying host drivers without having something to test against. So I started playing with devices that had really tricky handling. Good examples are, for example, the BME 280. One of the reasons I decided to start using it is that it supports both SPI and I2C, but the way the protocol works in SPI is very different from I2C. So I wanted to be able to write a device driver that would be able to talk both the dialect, but in a way that would abstract out the fact that underlying there's a different protocol involved. On the SSD 1306, it's also a dual protocol device that can talk I2C and SPI. But the difference there is that it actually, first, it's a write-only device, but also when you write over SPI, you have to play with one of the CS line kind of manually. It's kind of weird. Or you can use a 9-bit SPI protocol. Actually, I haven't finished it, but that really helped me understand better what feature the host driver, the SPI host driver, had to expose, basically.
Yeah, one thing I saw too was you have one wire support, which is kind of fun. I'm actually using that for some temperature sensors that I have for thermocouple sensors.
Yeah, actually, the one wire hasn't been written by me at all. It's Thorsten who wrote it. Gosh, I forget his full name. I'm sorry. Thorsten van Aken. He contributed a lot, really a lot, to the project. So he was the one that did all of the one wire code. So he started with a device that is connected over I2C and then can expose a one wire bus over it. So basically, the nice thing about that is that if you register this device, then the one wire bus can be registered on the one wire bus registry, and then you can access the one wire bus transparently without knowing that it's actually over another bus. And that just works. He also wrote, he designed the periph tester board. So basically, it's a board that has EEPROM and the device that exposes one wire. And so basically it can test SPI, EEPROM over SPI, if I recall correctly, and EEPROM over one wire. So this way we can make sure that all of these protocols are not broken by any kind of change, basically. So it's really awesome. It's being tested continuously. So basically every time there's a change pushed, the smoke tests are tested on this board.
That's awesome. So I think we are a little over time for our first sponsor break. So let's take that. And then I want to talk to you a little bit about some of the kind of performance stuff. I know we chatted behind the scenes a little bit about some of the performance differences, like using this for doing things like bit banging.
Perfect.
So our first sponsor for today is TopTal.
Hey everyone, Adam Stacoviak here, editor-in-chief of Changelog. Our friends at TopTal have been sponsoring our podcast for years, and now they're sponsoring GoTime as well. We think they're one of the best ways to hire developers and designers, as well as one of the best ways to freelance as a software developer or designer. Head to toptal.com/go to learn more. Tell them you heard about them on GoTime. If you'd like a more personal introduction, email me, adam@changelog.com. And now back to the show.
All right, and we are back talking to Marc-Antoine. So just before the break, I wanted to hear, we were talking about kind of the performance differences, and we had talked a little bit about how you kind of have the DMA, the direct memory access support, and you had done some things for performance of bit banging.
So it's still a work in progress, so it's not fully live yet. So basically what I realized is, and that's actually one of the reasons I decided to go with this project, is that there's already C projects that do bit banging, leveraging, abusing the DMA controller. I think it's a better word in user mode. And basically, the idea is that you memory map the GPUs and the CPU's DMA controller registers, and you start messing with it live, which is actually a very dangerous thing to do. But experience has shown that it actually works. And the idea there is that basically you tell the GPU, you tell the GPU to allocate physical memory for you, and that part is working. And then after that, you tell the DMA controller to take the memory there and bang it to the GPIO registers. So this is kind of a funny idea. So basically it works in C. There's Python bindings, which is the RPO. I forget the exact name, but it's a very popular library. And I basically said, well, let's do one in Go so that there's no other need for requiring any C libraries to do that. So I started playing with that, and then I realized, if I want to do this kind of stuff, I need to do it in a way that works on multiple CPUs. So then I started working on the Allwinner CPU. So I have a few boards based on Allwinner CPUs, and I started looking at it. After a lot of look into the very deep into the CPU architecture, I realized that this family of CPUs do not allow access from the DMA controller to the GPIO registers. So that actually this mechanism cannot work on these processors, sadly. Someone on the RC channel, Sanxi on Freenode, helped me with that, because otherwise I wouldn't have never figured out. I forget the name of the person, but thanks a lot. But on the other processors, for example, like the BeagleBone, it could be possible. I just didn't get to that point yet. So basically, the idea there is really just that you can do bit banging and have it done by the DMA controller, or the reverse is to basically have your own logic analyzer, basically, that can run without having to take a full CPU. On the other hand, because it's using memory map GPIO registers, you can actually read very fast, and basically you can abuse the system by taking a full core and have this full core just doing a busy loop of reading a register. Then you just happen that to a circular buffer, basically. And then another core can just update that to the UI, basically. So that's one of the things I was actually looking at probably doing. where it's purely CPU based, so it takes a lot more processing power. But on the other hand, you don't need any kind of messing with the kernel. So that's actually a saner option.
And I know a lot of our listeners too probably aren't all hardware people. So maybe we can talk a little bit about like what DMA is and why you would want to use that.
Yeah, sorry about that. Yeah, that's a good that's a good point. So basically, DMA means direct memory access. So it's a kind of a small controller inside your CPU. Well, aside, but mostly in the chip that can do bit shoveling basically. So it can copies memory from one page to another on the behalf of the CPU. One of the big use of that, for example, is when you're reading from a hard drive. For a long time, the hard drive has been doing DMA for pushing the bits from the hard drive to the memory on the behalf of the CPU, but without having the CPU to bother with it. And then at the end, just says, "Hey, I'm done. Here's the bit on the page." So it really helps because then you can do these, which takes time, but without incurring any cost on the CPU side. So it's very important on single core systems. So for example, if you take a Raspberry Pi W, the Zero, you only have a single core. So in that case, you really need to free up as much as you can. So that's one way to achieve that.
Now, while we're talking here, I installed perif.io on the Raspberry Pi that's running my barbecue grill right now. And on that particular board, we've got pin 22 that controls the relay that turns the fan on and off while the blower controls the temperature of the barbecue grill. And I just set that with a watch command on the terminal, and I'm watching the output of your GPIO-list command that comes with perif.io. And it's so much fun just watching GPIO22 go from out low to out high, out low, out high, as the fan goes on and off. These are some really great tools. There's 3 commands that are shipped with perif.io. There's perif-info, which I pasted the output of that into the Slack channel. And then there's headers-list. And then there's GPIO-list, and all of them worked beautifully on the Raspberry Pi that I have. That's really cool.
Actually, there's even more than that. Let me paste that on the channel. I wrote actually that one of the first way that I decided to test devices was to write one executable per device driver. So you're not required to use them, but it's a nice way to figure out how to start your application, basically. So if you want to use, for example, the APA 102, you can just look at it, and it already has functionality, for example, animating the lights based on a ping image or things like that. So most of them are not, I really meant to make sure that your device works well. They are not necessarily exposing a lot of functionality, but enough to be able to get by. So the GPIO ones are really useful when you just want to do a quick switch of value or just reading quickly, and it's pretty nice.
That's awesome.
So I think you had mentioned too that you had been playing with like the Pocket chip too.
Yeah. So the Pocket chip is kind of neat. Basically a chip, so it's a very low power single core system with half a gig of RAM. It runs like a custom distribution that is based on Debian. And it actually exposes I2C, SPI, and a few GPIO on the top of it. So actually, my goal has been to expose the basically you can connect a FLIR lepton, so then you have a portable infrared camera. It's not fully working yet because I've been fighting a lot with the SPI driver on the chip. But beside that, it's a pretty nice hardware because it has its own battery, so it can actually last a lot, many hours. I've been using it for like 5 hours, and it was fine. And you can actually build on it. So I literally just started up VI and edit my code and build my Go projects on it. So it's a pretty nice device for that.
Do you prefer it over a Pi?
Well, it's different because the chip is much cheaper than the Pi, and it has Wi-Fi, which one I think it got announced before the Raspberry Pi 3, which had Wi-Fi. So it's a different market. The Pi is incredibly faster, but on the other hand, you have to buy a SD card, while the chip already has 4 gig of flash on board. So because of that, the total cost of the chip is much lower. And the fact that it has a battery connector included is also a plus, because then you can run. It's very, very easy to run it on a lithium battery, and you can charge. It can charge the lithium battery too. So because of that, the use case are slightly different than the Pi. So it up to an extent it's closer to the Pi Zero, but still the Pi Zero doesn't have a battery charger as far as I know. Actually, just got one in the mail, but I didn't have the time to open it yet. So for embedded stuff, or not embedded stuff, but for stuff to be carried on, it's very nice. So yeah, it's something I really like a lot. One thing I wanted to backtrack though is when I started the project on Purif, is that I wasn't sure if I were going to do it or not. And Thorsten van Iken, which I referenced to earlier, he reached out to me in September or so of last year, and he was already contributing to Embed. And then he looked at the way I was discussing the design. He was like, "Oh, I think you have a point here, and it's really worth." So basically, I use this knowledge in this area to be able to have someone to discuss with until the project became public. And he did all of the code reviews, which really helped me to structure the project. I decided to make it private for a long time because I really wanted to refactor the hell out of it. And basically, when you have a project and you have no user, you cannot break anyone. So that's the best thing ever, because then nobody's complaining, they are not using it. But the problem is that eventually you want to have users. So the line there was when to make it public versus keeping the liberty of breaking the library as much as I wanted. And eventually I got the pressure to actually release it, because eventually I just wanted to have something people wanted to use it. But at the same time, I still feel that it's not, I haven't feel right now that it's not good enough in the design. And I really want to change a lot of features. For example, the SPI driver, I'm not happy still with the current design of the interfaces.
So you mentioned a Go HCI. Is that a CI system that you built specifically for this package? And can you kind of describe how that works?
Yeah, so Go HCI is basically my CI system for the cheaps. So for the cheap people. So basically, what happens that I was at the point where I had to decide if I were to pursue that as a project or just leave it there and it works and it's fine. And I really felt that if I wanted it to be a real project, it needed three things. First, the design I could be happy with it long term. Second, a way to ensure that the quality of the code itself stays good. And third, a website to host the documentation. So I worked on the quality of the code with the Go HCI. So basically what it is it's really a cheap hack. So it runs a service. Basically, I started via systemd, and it exposed a web server, which basically you trigger GitHub webhooks. And when there's one that based on the parameters, it decides to do a test run based on the commits on the PR or the commit that is referenced by the webhook. And basically, what it does is that it runs a predefined set of commands. So basically, it's the same as Travis or any other CI system, or for example, drone that you can also run locally. The only thing is that I didn't want to pay for a server because I'm super cheap. So, so basically, what I decided to say is that, well, actually, on GitHub, you can save you can save GIST, and it's actually free, and you can save multiple files inside the GIST, and well, it could be just the stdio, the std out of the commands being run. So I started playing with this idea. I just wrote a hack in 3 hours, and I realized that it was actually working well. So I generalized it slightly more, but not too much. And I really wanted it to be a solution specifically for hardware testing, which you cannot use with Travis or any other kind of services. Well, actually, probably Travis you can do, but I wanted to try with the free implementation. So the nice thing with it is that every time there's a commit, it will run, but the tests are specific to the hardware it's running on. So for example, if the board running GoHCI as a tester board, it will run the smoke test related to that. Otherwise, I can run the GPIO smoke test to make sure that edge triggering is good or things like that. So there's actually a fair number of smoke tests, and the smoke test tests all kind of logic in the library that is better tested when you have hardware to test against. So there's still a unit test, and the unit tests are run on Travis, and it works great. But sometimes you're testing also the operating system underneath and the hardware itself. So I really wanted to have the distinction between the hardware testing and the unit testing. And it's kind of the side effect of my work day, my day job, basically, where I'm working on the Chrome infrastructure. And I've been working on that since 2008. And Chrome is a really large project, and there's a lot of unit tests and a lot of smoke tests too. And the current scale at which Chrome runs is pretty intense. There's like over 200 commits per day, and a single test can represent up to like around 30 hours of test for a single commit. So the scale at which it runs is very high. And I was like, yeah, let's do the complete reverse. Like, do something very, very simple to see how far I can go. So that's basically how it happened. So yeah, it's very, very focused project for a very single purpose job. It fits the deal fine. So I'm very happy about it.
That sounds amazing. It sounds like it would be a really good blog post.
Yeah. Yes, I should. I'm really not good at writing blog posts. Actually, which brings me to the website. I had a lot of pain to create the website, and one of the fun things is that I realized that there was the freebie Google Cloud VMs that you could get, like the very, very cheapest one, which had like a fifth of a CPU, and I was like, yeah, there's something free. So so I started playing with it, and one of the hack I did is I used there's an image there that is based on Chrome OS, and they call it Container OS. But basically, the idea is that the only thing you can run on it is Docker. And so basically, what I said, well, you know what? If it can run Docker, it can run Caddy. So my idea was, let's see. And basically, what I did is that I fired up a VM. I look at all the paths that were mounted as executable, and I just SCP'd Caddy there and tried to run it. And obviously, it worked because of Go static linking. So basically, I completely abuse the operating system there to be able to run Caddy out of a Docker image, and it works incredibly well, actually. So that's pretty neat because the operating systems takes like pretty like 100 and a half, maybe 150 megs of RAM, and Caddy itself like takes maybe 15 meg of RAM as resident RAM. So it's very, very low memory system. and it works great in this situation. But writing this website, because I knew that the website was very important and that documentation mattered, but at the same time, I'm not that good at writing documentation. So a lot of iteration went on that before making the project public. And one of the nice thing is that I asked my daughter to draw the mascot. And at first, she was kind of afraid of doing it, but eventually she accepted to try it out, and so she drew the small mascot there, which I really really like. So I'm very happy that she did.
Yeah, that thing is adorable.
Yeah, it is.
He's got his little wired up backpack and the LED.
Yeah. So a lot of things also that I did was doing outreach to people. One of the first person I tried to talk to was Yana. That actually I kept contact with her for pretty much the whole cycle. I also discussed with Ron from the maintainer of GoBot. He's a very busy guy, but was able to get a hold on him for an hour and a half. I was very very glad that he took the time to talk with me, and we've discussed ways where the bigger picture would fit. So basically, my take has been that I actually don't care that much about writing device driver. As I said before, most of the device I wrote were really just to test the underlying code for the host operating system drivers. So I tried to position the library as much as low level that would fit under GoBot. That said, it's not a given that there's a way to make everything work as much as I'd like, but that's definitely the goal I'm trying to aim for. Basically, as I wrote in the web page, as an enabler to be able to access as much functionality as it's exposed by the operating system. So yeah, I'm hopeful that we'll continue working together. One of the things actually I'm trying to make work Go HCI with pull request better, and I'll probably fire up like the first GoBot worker there. So if that works well, it's going to be great.
That's really cool. I'd love to see these two projects work together more if possible.
Yeah.
GoBot is a great project, and the perif.io looks pretty darn amazing to me.
Yeah, one of the reason I decided to start my own stuff instead of contributing upstream directly is that actually I didn't know what I wanted, and I didn't know how it would look like, and I felt that I really needed to experiment a lot. So, and if you look at the history of the commits, it's like you go back in time and you see all the packages are different and the interface have been shuffled around a lot. And I don't know, maybe I'm just a visual person, but I really needed to have a tangible view of the interfaces to see if it felt right or not. And doing so is basically this killing the usability for your users, because you're continuously breaking people. And so at the beginning, most of the work was soul searching up to a point where I really wanted to explore all the different kind of designs and see the ones that I felt were the best one. And for example, the registries, there's a lot of small registries. And these registries really help to, for example, to have a domain-specific set of known devices or something. So for example, there's a GPIO registry, but there's also the registry for each of the buses. And I don't know if it in the end people will actually think it's a good thing, but I think it is. So I decided to do it, and I feel that it's kind of neat because afterward you don't preempt for a specific board anymore, and that's one of the things I really like is that all the boards are really abstracted away. You just have a string for the name of the GPIO you want to use, and you can use the string of the pin from the board name or from the CPU name or any other kind of aliases that you want. And that's the only string you need to change to be able to run on a different kind of hardware. And I felt it was pretty neat because you don't need to reference packages that are board specific. They are there if you want to use them, but you're never required to use them. And that was one of the key points I really wanted to focus on.
So you had mentioned you were playing with some other things for hardware-based projects too. Like I forget what episode it was, but a few episodes ago we had talked about Go Crazy, which was kind of like an interesting way of creating Go applications and just deploying them out to, your Raspberry Pi without thinking about it.
Yeah, it's kind of an impressive project. So I played with it a bit. Proof sadly doesn't work on it yet. I tried to commit on fixing it, but I didn't. But there's a lot of challenges on this project because you obviously need to write a ton of code to make it work. But I really like the idea of just getting rid of C completely. As a C, as a next C++ developer, I'm fully behind with that. So so that's a very interesting route. And so my big question, if it's going to be able to attract enough developer to be able to make it into a fully supported platform. But if it can, for dedicated devices, it's very neat because first it implements the dual partition mechanism that is used in Chrome OS and also used now in Android, where you basically have two copies of your operating system. And when you upgrade, you just upgrade the copy that is currently not used, and you reboot and you just switch the pointer to the other partition. And that's really amazing because you can do upgrades in a way that is very safe and very simple to do. And then you just mount a third partition to be the partition that you have your user data. So that's basically the mechanism it uses. And I think it's something that is the way of the future, basically. It's just implementing the way of the future takes a lot of work, but I really hope that it's going to become more popular.
Yeah, and I mean, CoreOS also does the two partitions where it upgrades the kernel into one and then switches them and fails back.
They use Chrome's update system to do that.
That's true. Yeah.
Yeah, actually, it's also based on Chrome OS. So yeah, Chrome OS is a great operating system, but Chromium OS. But yeah.
Carlicia, is your Chromebook purchase sounding better and better now?
Yeah.
Now is that called what's the name of that update system? Omaha. Is that right?
Is it using? No, it's. I'm trying to recall internally. Good question. I forget. I recall this server code, but yeah. I'm trying to recall what's open source and what is not.
Secret thing. You know what I ran into on the internet 2 days ago? I was doing my typical late night surfing through GitHub thing, looking for interesting projects to star and talk about on the show. And I ran across a fork of CoreOS that Jessie Frizzell maintains. And it looks very clearly to me, like in her fork of CoreOS's build scripts, that she is using CoreOS as a desktop OS because she's added X11 and all kinds of other stuff to it. And I can't wait to find some time to talk to her about that, maybe at GopherCon, and find out what that looks like. That is crazy. Because CoreOS, it's got Chrome's updating system, but it's Gentoo in the background. So it's really powerful, how you could build a whole OS just by changing a couple of config files and rerunning a script and waiting a couple hours.
Yeah, but my main feature request for Chrome OS would be to be able to run Docker images. So that's kind of aligned with the idea. I think it would be a great idea, but yeah, I failed to convince the leadership to get that.
Just build your own.
I could. It's more work. The foundation there is really good, and that's very interesting project. It's funny because right now I'm using a MacBook Pro, and the only reason is that it's the only laptop where you can connect 3 different monitors to it. So that's literally the only reason. I only run a shell terminal and to another workstation and Chrome, and that's it. That's really the only thing I run in it. It's kind of sad. Yeah, so one thing I would really like is that actually one of the sister project, which is named Skia, they started a lab. It's I don't have much detail to give, but one, which is really nice, which basically what they did is they boot the Raspberry Pi from the network. So I don't know if they will be happy that I'll talk about it. But the idea is basically you create a really, really small boot partition that basically just mount over NFS, the real file system, and then you boot from there. And one of the nice thing with that is that then you can basically boot all of your Raspberries. The flashing the card is extremely fast because it has almost nothing on it. And then you just connect your Raspberry Pis, and then they just boot the operating system from your server. And whenever you want to update the operating system on the Raspberry Pis, you just update the OS image shared over NFS, and that's it. And that's actually one thing I would have liked to do with UHCI, because then I would lose the problem of persistence on the workers. But then I would have to do it for a lot of different boards, and it's work. And yeah, work is hard. So that's the problem I'm facing right now.
So one other cool thing that you were working on was actually an kind of like a VI clone, right, in Go, and now it's in Rust. But
Yeah,
how did that turn out? Most all of us wish we could get rid of Vim script and just write a new.
yeah. Basically, yeah, I hate Vim script with a vengeance. I don't know. It's just a horrible language, and I love Vim Go, but I mean, I cannot make any sense of Vim script otherwise than that.
I feel for Fatih for the amount
Yeah,
of Vim script he has to
my
write
God.
to make it work.
Yeah, it's incredible work, but oh my God. And so yeah, I actually had been experimenting with that like 6 or 7 years ago. And that's something that I had on the back of my mind, but I knew that it was a lot of work to try it out. And basically, I wanted to do an experiment. And the experiment basically was to have a client server version of a text editor, where the front end is a client, and then the backend is actually the one doing the I/O for the files and things like that, which is kind of hilarious when you think about it. And you're now to the point where your text editor is a client-server architecture, but it's a great idea. So the reason I wanted to do that was my feeling was, well, then you can just go get all the plugins you want, and you make the plugins as out of process plugins, and you just communicate with the plugins with I was using NetRPC with GUB and encoding, but the idea was you make sure that the interfaces fit are exactly the same. So basically, I wrote a hashing algorithm of interfaces through reflection. So basically, it's kind of a COM-GUID, but with hashes, which where really my Windows experience shine through there. But the idea is that you use reflection to enumerate all the methods in the interface. And if it references structs, you also go into these structs and hash all the public member of the struct, and you recurse until you go to the end and you have only basic types. And you hash each of the names and the types, and you add zeros and null character in there, and you basically generate a deterministic hash in the end, and that represents a way to communicate with another party that the interfaces that you're using are exactly the same. So then you get a form of binary compatibility, because you know that both are using exactly the same structure definitions. So I started experimenting on that, and then out of process plugins and things like that. But the problem is that I forgot to actually work on the editor part. So so basically, the editor part was really crappy, but the rest was really great. And then Ralph started working on. So basically, I named the editor WI because it was like a follow-up of VI, and it was kind of a pun on that. And then Ralph said, "Well, you know what? I really want to try it in Rust instead." So basically, the thing is that he actually knows how to write a text editor, unlike me. So he started writing it, and it's pretty amazing. So it's the core idea is slightly similar, except that it's in Rust. But the thing is that he's using JSON RPC instead of binary format. And the thing is that the encoding in JSON is trivial compared to everything else. So it's actually not a performance issue at all. But on the other hand, then you don't actually have any kind of language lock-in. So because of that, you can write your plugins or your front end in any language, and it doesn't matter anymore. So it's actually a net win. It's much better in practice. So yeah, it's. I just need to learn Rust though, so I haven't got to do that yet.
I wonder whether gRPC would be a good option as well, because they have support for a number of languages now.
Yeah, but I don't recall if you looked at it, but I would have stuck with JSON RPC too, because the thing is that most of the time it's local. I mean, you're running the front end and the back end on the same system, so bandwidth is not too much of a problem. Then there's the performance of the amount of data. So gRPC is more compact than JSON RPC. But on the other hand, gRPC implicitly depends on HTTP v2, where JSON RPC is very easy to just do over a dump pipe, basically over STD out and STD in. So in practice, it's simpler to use JSON RPC. And because of that, it's simpler to do it in languages like using Node.js or things like that. So I think I will use I will use the same idea. I wouldn't use gRPC because of that.
gRPC would be fun though if you could have a UI on your local box and then just host the server side somewhere else. Because if you're going client server, they don't necessarily have to be on the same host, right?
Yeah, I think it's actually a goal. I haven't tried personally. I would have to try out, but I think it's one of the goals actually to be able to do that. For example, actually one of the nice advantage of doing the way it's done right now is that actually the front end could be a web page, basically. So then you get to the Cloud9 territory or things like that. But the nice thing is that then your plugins are still running on the host. They are not running on the web server itself.
That would be really nice. I'd enjoy that a lot.
Having a web-based editor.
No, just having the server being a different machine. You know, I could have a Linux desktop or Linux headless server running all of my code, but the editor be on Windows or Mac.
Or your Chromebook or...
Yeah, absolutely.
Yeah. So, yes, I think it's basically the root of the future. The thing, I don't know, it needs to happen, basically. It just needs to happen. I just need to get out of Vim eventually. That's really something that needs to happen eventually. Because it's funny, because every time, like, for example, I get to a Raspberry Pi, I want something that I can start working on it right away, and I don't want to mess with a lot of packages. So if I can just SCP executable and start being productive, it's going to be awesome.
Okay, so I think we are just about out of time. But so one thing we like to do at the end of every episode is we do something called Free Software Friday, where all of us kind of give a shout out to just a project or a maintainer, and it does not have to be Go, of an open source project that kind of makes our lives easier. Does everybody have a project they want to? And Marc-Antoine, if you have one, that's awesome. If you don't, that's cool too. We'll just kind of go around. Carlisa, did you have a project you want to mention this week?
I do. It's called DocOpt. I think it's called DocOpt.
That'd be my guess too.
Yes, it's DocOpt.
DocOpt. There we go. I knew there was something there that I wasn't doing right. I just thought it was a really well organized project. I love it that when you fetch the arguments, you specify right there if it's supposed to be used as a Boolean or string. So I might use it when next time I need to do a CLI.
Oh, that's really awesome. How about you, Brian? Did you have anything?
I do. I played a couple days ago with WX Go, which is a WX widgets wrapper for Go. And we've been bemoaning the lack of GUI capabilities in Go for a long time. But this repository, which is at github.com/don'tpanic92/wxgo, is incredibly complete and works beautifully. I tested it on Mac, Linux, and Windows using a really small app that I wrote because I'm not a WX widgets expert. But the exact same code compiled and built and looked native on all three platforms. And I don't know what else people would possibly need out of a GUI than that. So I was really impressed. It's nice to work with as far as writing evented window management things go, and very complete. No panics, no crashes, no runs, no drips, no errors.
Nice. How about you, Marc-Antoine? Did you have anybody you want to give a shout out to, or any projects?
Yeah, well, I think you talk about it every week, but Caddy is really awesome. And yeah, I wouldn't be able to live without it. The other thing is I actually started playing with Shiny and from Nigelto, and it's pretty cool. In my case, it's actually to be usable on the Pocket Chip, and it made it really trivial to be able to just open a full screen window and start drawing onto it, which is very useful for my use case.
Oh, cool. What library is this?
Shiny. So it's actually on the X repository on Golang. I'll just paste the link.
That's the experimental GUI layer.
Yes. So it's very experimental, but it works, and that's good enough for me.
Now, the one I have is actually something I recently came across, and here's a pronunciation thing, and thankfully on their README they tell you how to pronounce it. It's called Hecit, and it's they call it the hex editor from hell. And I can say that on air because it actually says that in the slogan, so it's not me swearing. So it's like a tabbed interface, but you can it's a hex editor. But the cool thing is like you can use Vim commands to move around it, and most of us on the show love Vim movement keys. Basically, you can hit key combinations to switch the endianness or the way the bytes underneath your cursor are interpreted. So you can look at them as like integers or as strings and change the endianness around. So it's actually really cool for looking at just a file of bytes, trying to kind of reverse engineer what it is. And I'll post a link in the GoTime channel for that. And with that, I want to thank everybody for being on the show this week. Especially thank you to Marc-Antoine, and happy birthday to Brian.
Yeah, happy birthday.
And where's the singing? I heard there was going to be singing. I
thought we agreed we were never going to sing again.
Yeah,
I was promised singing.
The latency was so bad.
Gosh.
We need, I don't even think Jonathan Youngblood can save us in the editing for that. He does amazing work, but I don't think that's fixable. So huge thank you to Marc-Antoine for coming on the show. Shout out to our sponsor, TopTal, for helping make this show possible. Definitely encourage everybody to share the show with fellow Go programmers. You can subscribe by going to gotime.fm. We are at GoTimeFM on Twitter. If you want to be on the show, have suggestions for guests or questions, topics, hit us up on github.com/GoTimeFM/ping. And with that, bye everybody. We'll see you next week.
Thanks a lot.
Happy birthday, Brian. And bye, everybody.
Thank you.
Happy birthday.
Thanks for coming on, Marc-Antoine.
Yeah, it was great.
All right, that wraps up this episode of Go Time. Tune in live on Thursdays at 3 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time at thechangelog.com/community. Follow us on Twitter. We're at GoTimeFM. Special thanks to TopTal for sponsoring this show. Also, thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. This episode was edited by Jonathan Youngblood, and the theme music for Go Time is produced by Breakmaster Cylinder. We'll see you again next week. Thanks for listening.